All right, so Alan and I are going to discuss two different ways that BTF can really help modernize common workflows. First, kernel debugging, and then Alan is going to describe how it can help with packet capturing. So if you've done any kernel debugging before, you probably, or at least interactive debugging, you're familiar with a lot of options. There's probably KDB and KGDB, which are built into the kernel. You have the set of GDB-based debuggers and the extensions for kernel debugging. And then finally, you have independent debuggers like drgn, which is built on Python scripting. And all of these are great, and they all have a requirement for debug symbols, except for KDB. The reason for that is that KDB can benefit from some of the built-in information in the kernel, like kalsims. So right now, we have at least three really important pieces that could help debuggers work. We have kalsims, a symbol table, which contains information about the offsets and names of all sorts of symbols in the kernel. And most distribution kernels enable kalsims all, which means that we include not just function information, but also variables from all different sections of the kernel. Second is orc, a stack unwinding format. In case you don't use frame pointers, you need a way to figure out where each stack frame ends. And this is roughly similar to DWARF CFI, but built explicitly for the kernel. And then finally, we have BTF, which enables really all of the other features of a debugger because it can describe C types, such as the struct layout, the member name, things like that. And this is essentially similar to the DWARF debug type information. So our goal is to take these different self-describing components together and merge them and allow basic debugging tasks to happen without even referring to an external DWARF file. So this would enable things like drgn or GDB to debug a live running kernel via proc kcore, or a core dump triggered during a panic, maybe, without needing to open, a symbol table in an ELF file without looking for those DWARF information. But of course, we're not trying to replace all features of DWARF. There are a lot of really detailed, lots of really good data that DWARF can give you, like source code mapping, and the kernel just doesn't have space for all of that. So these are just the core features we need. So the steps to get this all working, we've got at least three work streams going on. First, kalsim symbol data wasn't able to be found in a core dump. And as of Linux 6.0, this is resolved. We record where the symbol table is inside of the VM core info node. So if you load a crash dump, you can find that symbol table and start parsing it. Second, BTF data currently only uses or has data for function and per CPU types, but we've got a work in progress series to address this by generating all types. And then last, no debugger yet understands BTF or kalsims, but we're working on upstream branches for drgn to add support for that. And next, Alan's going to tell us a little bit about packet capturing.
So if you've used Wireshark or TCP dump, you're probably familiar with capturing network traffic, and that happens at specific tap points in the kernel. But funnily enough, the BPF type format can help here as well. So with eBPF, we can be a little bit more flexible. So having that type format information can tell us about kernel functions and what arguments they have. And using that information, we can then identify the functions that have an skbuff, which is the network metadata data structure. And if we know which functions have one of them, we know we can gather tracing information from those functions as well. So in this case, the user is specifying a function name as a device, and because we have BTF, we can then go and take that function name and figure out if it has one of those skbuff arguments and which argument it is. So for example, here we're running TCP dump on a kernel function. This is the function to scan Wi-Fi. And importantly, we have to specify link type here because we don't have, unless by default it's going to be Ethernet, but for a lot of kernel functions, we might be higher up in the stack before the Ethernet frame is being prepended, or you might be somewhere else like in the Wi-Fi stack. So we need to specify which type of link we're dealing with here. We can't just assume we're dealing with Ethernet. So if those changes are made in libpcap, then Wireshark and TCP dump can take advantage of that, and we can sort of have a much more flexible way of capturing packets, which can be very helpful for kernel debugging. So in summary, kernel debugging and packet capture are things that we've kind of been doing for forever, really. But with BTF availability, we can see there's new possibilities. For debugging, we don't need to rely on expensive external type information when we're doing simple debugging tasks. And we can simplify other tasks as well. So packet capture at arbitrary functions becomes simpler because we don't need to specify any details about the function aside from its name, and we can gather the information then via BTF and trace that information effectively.